Hey, this is OXDF. Today we're looking at the Advent of Code 2016, Day 17, 2 steps forward as part of the revival of Code 2023. Let's take a look at the challenge. This is a very complicated setup here, but basically what it boils down to is I'm going to start with some kind of salt. So that's my puzzle input. In the example, they start with HIJKL. And then I start up in the top left room of a 4x4, so 16 room grid. The goal is, if I'm in 0, 0, the goal is to get to 3, 3, and you're done. When you're in a room, there's doors, there's walls around the outside, and then there's doors, and you have to check and see if the doors are unlocked. And the way you do that is you take a hash of your salt plus the moves you've made so far. So in the first room, we'll take a hash of our salt, and we look at the first 4 characters, which map to up, down, left, right. And if the character is B, C, D, E, or F, that means that door is open. Otherwise, the door is closed. So number or A. So when they start with their, let's see if on their example, their first hash starts with CED9, which indicates that up is open, down is open, left is open, and right is open. Now, if we're in the top room, up is a wall, so actually it's not open, and left is and down, so we can go down. Left is a wall, so it's not actually open, and right is closed, so we can't go there. So the only option is to go down. Now you go down, and the next thing you do is you add your D for down, capital D, to your salt, and you hash that again, and you do the same thing to figure out what doors are open. And so it produces this. So up is open, down is not, left is open, right is open. Now left you can't go because it's a wall. You can go back up. And in fact, interestingly, you can go back up and different things will be open because we'll have a new path getting there, completely different hash. So each time you go into a room, that might be different. So anyway, and you figure this around, and the goal is to figure out the shortest path to get to this last room. They give us a bunch of examples here. There's 3 different salts with the path that they would expect to get there, and then I've got my salt here. So let's go ahead and take a start. We'll do my genday script here for day 17. I have a video that describes this in basically how it works, but it's going to give me some stubs to work with as well as pull my input into a file here. We're going to start by writing tests. So we're doing test driven here. Whoa, didn't mean to do that. We do not need anything file based because we can get our input here. I'm going to start by first, before I even get to part 1 or part 2, we're going to start with a doors open function. And so from any point in the room, or for any salt plus path, I should be able to tell you what the doors open are. I'm going to pull this into my other screen so that I can easily copy and paste from it. And basically what we're going to do is we're going to take, let's see if I can find it here. So we know that like when I have HIJKL, I could go up, down, and left. When I had HIJKL and then D, my options were up, left, and right. When I did HIJKL DR, there were no options. We'll return that. See, we have a couple more here to do. So HIJKL down then up, and that returns right as an option. And HIJKL down, up, right. And in the example, that returns nothing. And then they say, good thing your salt isn't HIJKL because you couldn't reach the end. So we got puzzle. We'll call this salt, and we'll call this doors. This becomes salt, and this becomes doors. So I'm using this parameterized basically to say test all these different cases. And all we want to be able to do is call this test doors open. And we'll call doors open on salt, and we'll expect doors. We will want to make sure that that doors open function exists. We're not going to need a parse here, so we can do doors open on a salt. We can save that, and now we can come over here. I will come to run PyTest right here with F5. I do have a video showing how to get PyTest set up to work in this debugger here. I'll include a link here. Cool. So we've got a bunch of no, let's call it doors open, save it correctly. Let's just get to a point where we should be seeing, yeah, so right now my doors open function returns nothing. So this is going to be assert none equals this string. And so we're going to get a bunch of failures because none is, these should be equal. Perfect. Let's go implement. Let's see. We can even update the doc string. Return a string from up, down, left, right, for which doors are open. Okay, so the first thing we need to do is take an MD5 hash. So we'll come import hash lib. I think this is the third time we've worked off MD5s this 2016 advent of code. Honestly, it's getting a little tiring. I think they went away from that in the future. MD5 salt, like that. And then we want to get the hex digest from the result, and that should give me the hex string I want. Now, a cool trick I'm going to use, if I do a zip on the string up, down, left, right, comma, h, what zip does is it's going to take items from each thing and pair them together. So it's going to get me u and the first character in the hash. It's going to give me d and the second character in the hash. Give me l in the third, r in the fourth, and then because one of them ran out, it's going to stop. So it's exactly what I want. So I'm going to zip those together, and so we can say dir for dir comma results, I guess, in that if res in b c d e f. What this is going to do is it's going to give me the dir, one of these four characters, if res is in this string. So basically I'm going to get things back. So now I can just do a dot join on that, and now I'm going to have that as a string, and I can return that. And I think I may have just written this up real quick, but we're still failing. Let's see, strings must be encoded before hashing. Cool. See what we got wrong here. D equals UD. See, did I make a typo somewhere? Or let's see, BCD, right? We can do some tests here. Let's just make sure we have the right hash. So I put a breakpoint here. We can come to here and say h. That is not the hash I was expecting for jij. Let me check my other monitor here. hij, initially you have hash. It should start with CED9. But I don't have the order right. JK. No, try that and restart. Okay, typos. Typos always get you, man. All right, so we now have we can give ourselves a path to a salt. Well, a salt or a string here. I guess it's not really a salt because it could be the salt plus path. But we'll call it. That's fine. Well, maybe we'll make it s just for string. Make it a little more ambiguous. But that still works. We can F5 that. We're still good. Okay. So now we need to do a breadth first search through the thing. So let's come back here. We can go. We are going to do part one. Get rid of this not implemented now, and they give us some examples. So again, I can just copy these off the other one. So if the salt is this, then we know the result path is that. This is like one of the most example heavy ones they've given us, which is nice because I guess it could be confusing otherwise. We have this, and the last one is a long one. Oops, copy. There. So now we should come down here. We don't need a parse. What are we running here? This is going to be salt, and this is going to be path. So we're going to take in salt. We're going to take in path. We're going to run AOC part 1 on salt. We're going to output path. Beautiful. I think we can just straight F5 this right now, and we should get some failures. So we have failures where none is equal to D, none equals this path, and so we've got all nuns, which is exactly where we want to be going into writing our function. Now this function, I don't think is actually too hard. We've done this so many times now. I'm going to do from collections import deck, my preferred structure to work with here. You can say Q is equal, we've done this multiple times already, this admin of code, deck, and we need to pass in the state. And so the state is going to be an x coordinate will start in 0, 0, x, y, and the path, which should be what we need. Call this salt. So now we can do while q. The first thing we're going to do is going to say x, y, path is equal to q dot pop left. So get the first item off the queue. If x equals 3 and y equals 3, return path. Means we found the shortest path, because we're going to do a breadth first search, so we're guaranteed the first one we find is shortest. Otherwise, we'll say like options equals doors open passcode, not passcode, what are we calling this? Salt plus path. Perfect. Now we should get our options. We can say for options, option in options. So for each option, we need to check and see if it's a door. So we can say dx, dy is equal to, I'm going to go ahead and create a real simple, well, we can just do it right here. So we'll say, I think this will work. Up is going to be, if we go up, because we're starting top left is 0, 0, up is going to be 0, comma, -1. Down is going to be 0, comma, 1. Left is going to be -1, comma, 0. And right is going to be 1, comma, 0, like this. And I think we can just put right here of option. So boom, that's going to pull for us the dx and dy. So now, if we'll say xx yy equals d plus x plus dx, y plus dy, if xx is less than 0, or actually, why don't we just say if 0 is less than or equal to xx less than or equal to 3, and 0 is less than or equal to yy less than or equal to 3. So if we're not running through a wall, we will q dot append, and we get a, so we'll say, and the state there is going to be xx, yy, and path plus option. So each door that's open, we'll make sure that it's not passing through a solid wall, and if so, we'll add that to our queue as an option we could check next. And that, I think, is all we need. Let's we can F5 to test this. Boom, we're passing tests. Let's go ahead and run this on the current file. Oh, we got to actually do a little bit of work here to I guess we can just, I think this should be simple enough. Now we might clean this up depending on what part 2 looks like. Oh, we don't need, this will be puzzle input. This is just my stub now needs to be matched, like cleaned up a little bit to make this work. And we get a result here. No, we gotta whoa. Put this in here. Beautiful. All right, this looks short enough that I don't probably need to pause the video. But really we want to find longer and longer paths that still provide access. The paths always end the first time they reach the bottom right room. Okay. What is the longest length of a path? And they give us our examples again. Okay. So I think we just run this again. Let's see. We're going to do a little refactoring first. So the first thing I want to do is I'm going to call this run. We're going to refactor and make sure our part 1 still works. We're going to get rid of part 2. In fact, we're going to get rid of solve. We don't need that anymore. We'll just call this run. And let's see, we're going to need, so now we're no longer going to return here. So we're going to need now to start thinking about, okay, part 1 equals none. So if we hit the bottom room, if part not part 1, part1 equals path. And at the end, we return part1, comma, for the moment, we're going to call it none. Does that solve me still? Let's see, we're going to run a lot longer, but not too much longer. We'll see. Oh, wait, hold on. We definitely need to take care of something. Okay. Also, even if we don't update part1, we got to continue here because we hit the final room. We don't want to get more options. We don't want to add to the queue. I think this will run forever otherwise. Part1, yeah, that came back quickly enough. Okay, so the question now to track is what is part2? So I guess before we do that, we should write a test. So for part2, we get those examples. In fact, I'm just going to update this single test I already have. So we will clear out u. This becomes test run. I'll call this test part1/2. I'll make this run. And now we want salt part1, part2, part1, part2. So what we want to say is aoc.run equals part1, part2, like that. So if we run this, I hope we're going to get a failure. Oops, let's see, we need to change this back to PyTest. I hope we're going to get back a failure because it's going to have error collecting parameterized. Did I screw that up somewhere? Let's see. Oh, because we don't have three things. I should go ahead and add in the numbers that, I got this on the other screen now. 370, 492, 830. Give this a run. We are failing. We are getting. Yep, perfect. So like our part1 still matches, but our part2 is none and not 830. So we need to track that number. So that's what we want. Okay, now we got to write the function to do that. Part2 we'll say, in fact, we can just do, I don't know why I think that's nice, but we can do part2 equals none, comma 0. So now we've got part2 is equal to 0. Down here, say if len path greater than part2 equals len path with an equal sign. Now I think we just need to return part2. Could it be as simple as that? Let's give it a run. We are passing tests. We pass all the tests. Let's run the current file. 752. Beautiful. Not too bad today. Still took, I surprised it still took so long, but you know, pretty straightforward, no mistakes. So thanks for hanging out with me. I'll see you next time. Bye.